Hello viewers on YouTube. In this video tutorial, we are going to focus on series and parallel arrangements of resistors. We are going to go over some examples involving the connection of resistors that are both in series and parallel, and how to find the equivalent resistance of the combination. So first and foremost, it is important you understand when resistors are said to be in series and when they are said to be connected in parallel. Resistors are said to be in series when they are connected end to end. What are we saying in essence? If this is a resistor and we have more of it, such that they are connected this way, then we said they are connected in series. That's the visual illustration of resistors connected in series. So these are the endpoints A and B. So if this is resistor X, this is Y, and this is Z. Resistor X, Y, Z are said to be in series connection. Now what about parallel? Resistors are said to be in parallel when one end of the resistors tends to be connected at one point, while the other end of the resistors is connected at another point. What are we saying in essence? Consider this kind of arrangement of resistor X, Y, Z. So if this is X, this is Y, and this is Z, such that we have the connection to be this way. So if this point is point Q, and this one is point P, then we said resistor XYZ are said to be connected in parallel. And that's the visual illustration of resistors that are connected in series and in parallel. So always keep that in mind. Now let's try to make good use of this. Let's see how to find the equivalent resistance of resistors in series and in parallel. For resistors in series, the equivalent resistance R sub E, which is the most often written as that, okay, is simply equals to the sum of the individual resistors, or the sum of the individual resistance of the resistors. So that's X plus Y plus Z. So keep that in mind. For resistors that are arranged in series, their equivalent resistance is the sum of the individual resistance. Now, for the resistors that are arranged in parallel, the reciprocal of the equivalent resistance is equal to the sum of the reciprocal of the individual resistance. So that's the difference between them. For parallel arrangement, it involves reciprocal, while for series arrangement, it's just the sum straightforward. So that's it. Let's go over some examples. Example number 1. Consider this kind of combination. As you can clearly see, we have series and parallel combination. These two resistors are said to be in series, while this other two is in parallel. Now, when you have resistors, or you have a combination that involves series and parallel arrangement of resistors, what I recommend doing is to first and foremost focus on the parallel ones. Try and find the equivalent resistance of the parallel arrangement resistors, and then attach it with the resistors in series. So let's focus on these two first. So we know that the reciprocal of the equivalent resistance will now be equals to 1 over 5 plus 1 over 10. So that's 1 over 5 plus 1 over 10. Yeah. So that will be 1 over R sub E equals to, so LCM, let it be 10. So 5 in 10 is 2 times 1 is 2. So we have 2 plus 1. 10 in 10 is 1 times 1 is 1. So that's 3 over 10. Now if we cross multiply or multiply by 10 over 3, so we have 1 over R equals 3 over 10. By cross multiplying, we have 10 to be equals to 3 R sub E. Okay, and dividing through by 3. Oops, let me write it again. And we have R sub E to be equals to 10 over 3. And 10 over 3 is 3.33 repeating. So let's just have 3.33. Perfect. Now, this equivalent resistance of the resistors that are in parallel will now be in line with this one's in series. It will now be in series with this one. So that's why I suggest you find the equivalent resistance for the parallel arranged ones first. You understand? Perfect. So now the new connection will now be in this form. In terms of visual illustration, the new connection will now be this way. So this is the new connection. So this for the 3.33 ohms. So we have a 3.33 ohms. We have 2 ohms. And we have a 3 ohms. Now we can find the equivalent resistance for these resistors in series. So that will be X of E will now be equals to 3 plus 2 plus 3.33. So that gives us 8.33 ohms. So this is the equivalent resistance for this combination. And that's our final answer. And that's how to easily find the equivalent resistance for resistors that are combined both in series and in parallel. And let's consider another example for easy understanding. Example number 2. Consider the combination on the board. Feel free to pause the video and find the equivalent resistance of the combination. As you can clearly see, 2 ohms resistors and 6 ohm resistors are in series, but these 3 tend to be in parallel. So let's combine them first so that they can be in line with this and this, and then we'll find our final answer. So let's focus on this. So 1 over X of E, 1 over X of E will be equals to 1 over 3 plus 1 over 4 plus 1 over 5. And 1 over X of E equals, now LCM, that will be 60. So 60 is LCM. So 3 in 60, that's 20 times 1, that's 20. Plus 4 in 60, that gives us 15 times 1, 15. Okay. And 5 in 60, that gives us 12. And 12 times 1 gives us 12. Plus 12. So adding this up, 20 plus 15, 35. Plus 12, 47. So we have 47 over 60. Now 1 over X of E equals 47 over 60. Now if we cross multiply, we have 60 to be equals, because 60 times 1 is 60, to be equals to 47 X of E. Dividing through by 47, then eventually we got the value of the equivalent resistance for the resistors in parallel. So that's 60 over 47. And if I divide this using my calculator, we have 1.28 to the nearest 3 significant figure. So that's our final answer to the equivalent resistance for the resistors in parallel. Now, this equivalent resistance will now be in series with these two. So therefore, our final answer for this problem is negative this 1.28. Okay, then write that back. So we now have X of E to be 1.28. So final answer in this case for the series arrangement will be equals to 2 plus 1.28 plus 6. That gives us 9.28. So this is the equivalent resistance for this type of combination. Now for the new diagram, this will be the new diagram. Okay. Because those that might be wondering how it's going to look like. So that's it. So this will be the 2 ohms. This will be the 1.28 ohms. And this will be the 6 ohms. And that's our solution to this problem as well. On to example number 3. So feel free to pause the video and figure this out. As you can clearly see, we only have one resistor that tends to be connected in series in this case. So these and these are in parallel. So first, let's make this to be in series. Let's also make this to be in series. Before we do that, let's focus on this first. So X of E for these arrangements, I'm using red color for that. That will be, okay, the reciprocal 1 over arcs of E equals 1 over 2 plus 1 over 1, which is equal. So if the LCM is 2, we have 2 in 2 is 1 times 1, we have 1. Plus 1 in 2 is 2, 2 times 1, we have 2, which is 3 over 2. So 1 over arcs of E equals 3 over 2. And if we cross multiply, we got 2 to be equals to 3 arcs of E. And dividing 3 by 3, we got arcs of E to be equals to 2 over 3, which is equal to 0.666 repeating. Let's say 0.67. Okay. Perfect. So now let's focus on this one. So let me use green color for that. So 1 over arcs of E will be 1 over 3 plus 1 over 5 plus 1 over 5. The LCM of 3, 5, and 5 is 15. So we have 1 over arcs of E equals 15. 3 and 15 is 5 plus 5 and 3. 15 is 3 plus 5 and 15 again, that's 3. So adding this up, we have 11 over 15. And eventually, arcs of E, if you do the cross multiplication we have been doing, should be equal to 15 over 11. And if I type that into my calculator, 15 divided by 11 equals 1.36 repeating. So let's just be 1.36. Well, since we are not dealing with rational number, let's just have 1.364. Perfect. So this is the equivalent resistance for these resistors arranged in parallel. Now, this one and this one will now be in series with this 4 ohms resistor. So therefore, our final answer in this case will now be so final answer will now be arcs of E equals 4 plus 0.67 plus 1.364. So let's add that up using our calculator. 4 plus 0.67 plus 1.364. So I got 6.034 ohms. Okay, they are all measured in ohms because there's resistance. Don't forget. Okay, so that's our final answer to this problem as well. That is the equivalent resistance for this combination. On to number 4. For this number 4, instead will be an exercise. Feel free to share a solution via the comment section below. So find the equivalent resistance for this combination, and that's the end of this video. Thank you. Bye for now.